Hello everybody and welcome to another video lesson. Today's topic is going to be strings, and we have learned how to use strings. They're everywhere in the module. We displayed messages with them, we've processed user input, we worked with data. We're used to dealing with strings, but in this lesson we're going to learn more functions related to them, and I'll explain why things behave the way they do and how to use all the functions associated with strings effectively. So let's get started with a simple definition. So a string is a sequence of characters. It can be enclosed in single quotes or double quotes. And I'll go ahead and I'll open up a file so I can narrate and have some examples on the screen. So I have PyCharm open right now. I'm going to right click on the folder, add a new Python file, and then this will be our strings lecture.py. So you can have something like a string that we call a greeting, and we're going to give it the value of hello. Okay. And we can also use single quotes as well. And I'll put my dog's name here. Snubbles. Her name's Snubbles. Both versions of these are valid, so the choice is yours. Oh, and strings can also be empty. So you can have a string that has nothing. And then, as you've already seen, you can output your string variables to the console. So I'll go ahead and I will print these out. So I'll go ahead and run this. And then we have Snubbles, and then the empty string doesn't produce anything, but it is still there. Okay. All right. So something unusual about strings, or just kind of one of their characteristics, is that they're immutable, meaning that once we create them, they cannot be changed in place, which sounds like a limitation, but it does have benefits to it. So one of the benefits is that it makes strings safer and more predictable. It also allows Python to optimize its memory use and improve performance behind the scenes. So let's look at an example of this. I have a very short example of this in our introduction module, but we can go over it here as well. So we say my pet equals cat, and then we'll say, not word, my pet equals, and then we'll change the first character to a B. Yeah, so in the idea here is that I have a string, and then I want to change the first character, and we'll talk about this syntax in a little bit. It is indexing strings. We'll talk about this in a little bit. What this is going to do is this is going to change the first, or what it's intended to do is to change the first character of this string to a B. So I'll try to run this, and I get an error, and it says string object does not support item assignment. And this is the error that I was talking about, where strings are immutable. This data type does not support this behavior. So we can't change the strings directly, or the character directly. We can make a new string though. So I'll say my pet equals bat, and then we'll print my pet. Okay. All right. So this actually does work, and this works because we're creating a new variable. It does have the same name, and there is a discussion about how items are stored in memory with strings, but we're not going to, with just how things are stored in Python in general. We're not going to get into that too much. A basic explanation is that this variable was pointing to this value, and we now have created a new variable, and it is pointing to this value. And pointers are used behind the scenes, under the hood, in Python, but we're not going to go over them for this class. It's a little bit too in-depth. We don't go over pointers in this class. So this is fine. You can do this. This works because we're building a new string, and that is perfectly fine. This isn't modifying the original, it's returning a new object. All right, so that being said, let's talk a little bit more about indexing strings. So you did see me do this earlier, where I had the name of the variable and then the square brackets and then a value inside. And this is because since strings are sequences, you can actually access the individual characters of the string by the index. And the index refers to the position of that character in the string, starting from 0. Remember, last module we learned about lists and how the lists start from 0 and go up to however long the list is. So the first item in the list is indexed at 0. That represents where the first item in the list is. And that's kind of funny because there's like programmer jokes about how programmers count from 0 on, and non-programmers don't. But hopefully that little anecdote could help you remember to start from 0 if we want to refer to the first item. So in essence, what this is doing, my pet, square brackets, and then the 0, this will, if we use it appropriately, we can get the first letter of the string. So I'll say first letter is my pet 0, and then we'll print first letter. So I'll run this. And then notice down here, it is in fact a C. So let me see if I can make this a little bit. Oh, just 1 second. I want to make the letters on the screen bigger. 1 second. Okay, I have zoomed in. So I don't know if you're having this problem where you are, but to change the change how zoomed in you are with the ID, you just go to View. I don't know why it keeps doing that. It's so annoying. Go to View, go to Appearance, and then in the drop down, there should be Zoom. Yeah, so I'm at 200%, so that makes it a little bit easier for you guys to read. Yeah, I just thought I'd go over that since I had to do it right now anyway. Okay, and then can you make a guess what would happen or how we would index the second character in the string? So second letter. So this is 0, this is 1, and the A represents the second character in the string. So this would simply be my pet, and then 1. And then we will print second letter. Run that. And then it prints C. And then on the next line, it prints A. So that's all there is to it to get to index items from the string. And then you're going to notice that I think I mentioned it a little bit before, that this is really similar to how lists work. And strings are similar to lists in this way, that you can actually, that they are sequences, and that you can, that each element or each character is stored at a specific index that starts from 0 and increases to however long that string or that list is. But strings and lists are not the same thing. So even though there is that similarity, in your head, make sure that you have separated these two concepts completely. They are not the same thing. Strings are not lists, but they are sequences, and that is the tie-in, I think, that you should take away from that. Okay, I'm going to get rid of this stuff for now. Oh, also my pet is not a cat. It's actually a dog. Let's change it to dog. My dog's going to feel betrayed. I just picked my cat because I don't know, this was the first one that came to mind. But another thing we can do are negative indices. Negative numbers count from the end of the string toward the beginning. So if I want to print, let's see, my pet, which is a dog, and then let's say I put a -1 here. So this is actually going to get the last character from the string. So I'm going to run this, and it gives you the G. So we've changed my pet from cat to dog, and this is the last character in the string. It's a negative number, so this would be -1. I'm sorry, the G would be -1, the O would be -2, and the D would be -0, 1, 2. Did I say 2? The G would be -1, 2, and 3. Yeah, I got a little confused here because remember we mentioned that when we count in the forward direction, we're counting from 0 on to however long the string is. But when we count backward, we actually do start at -1 because we can't really have -0. That doesn't make sense. So we would actually start at -1 if we were counting backwards. This is really useful. This idea is really useful when we're dealing with the last character or the last few characters. And we'll touch on negative indexing and some uses with slicing in a moment. But this is kind of what it is. So we'll change this to a 2 so we can get the O and then drive that point home. That negative indexing allows us to access items access characters from the string in reverse order. And then, let's see. Let's change our string up. So let's actually think for a minute. How about we learn how to loop through a string? So strings are iterable. So let me actually put a little note here so we can be on task for what we want to do. So strings are iterable, and that means that we can loop through them with a for loop. So remember, we've used for loops mostly to do with the syntax for, and then we say like something in range of something else, for like x in range 0 to 3, and then print x. So we've actually we've done this before. This is really basic stuff. 0, 1, 2. That's the behavior of a for loop when we use the range function, where we have a starting position, a starting point, and an ending point of 3. That's this example. But you can actually loop through strings as well. And here's an example of that. So we'll say for letter in music. We'll say print letter. So this is a little different than the for loop that we had up here before. So this was an X, and X can be, we don't have to call it X. We could say for letter, we could say for animal, we could say for, like whatever we want to use as the iterable, whatever we want to name it, that's fine. And then here is what we're looping over. So we're going to loop over each character, the M, the U, the S, all the way to the C, and then we're going to print each character within it. So I'm going to press run, and then let me make this a little bit taller. And then we have an M, a U, an S, an I, and a C. And so this lets us analyze or transform strings one character at a time. So in this we have just printed out each letter, but we can do different things too. We can do analysis. We can transform strings. And then what if, so here's a fun exercise. What if we want to check for vowels? Okay, so we'll let's make a variable that stores the vowels. A, E, I, O, and U. We're not going to include Y. Sorry, Y, you're left out. And the word we're going to assess will be planet. Okay, so the goal here is to check the string word for these vowels. So to do this, do a practical example, we'll say for letter in word, and then in this case, word is planet, so that's what this is. And then this is the iterable. Remember, it could be anything we want it to be. We could call it Susie, but when you do your naming conventions, you want to make sure that whatever you name it should describe kind of what its purpose is, or what it's doing, or what it's going to store. So you want to have some reason to your rhyme, kind of bit. We'll say if, this is our conditional, we learned these a couple of weeks ago. We'll say letter in word. Okay, so this next line is a conditional statement, and it's saying if the letter, so if the current letter that we're on while we're iterating through the word planet, if it's in, sorry, this should say vowels, if that letter is in vowels, so if one of the letters matches anything that's within the string A-E-I-O-U, which is vowels, then we're going to use an F string. And we did talk about this in the last module. We'll say letter is a vowel. And just to hammer it in, F strings, when we put the little F in front of the quotation marks like this, and we use a curly brace, we can actually directly access variables and use them within our output directly, like this. So this is a really easy way to output whatever the value of a given variable is within a string. This is an F string. That's what this is. Okay, so I'm going to run this at this point. Okay, and we have a result here. It says A is a vowel, E is a vowel. So it looped through the string planet, so it got to the P. That was the first letter in the word. It checked if the letter is in vowels, is P in A-E-I-O-U, and it went through each one. And since it's not, it skips this and it goes to the next. So this actually, this condition was not met, so it just goes to the next one. And then the next letter is an L, and then it's kind of the same story here, where L is not in A-E-I-O-U, so it skips, and then it gets to the A. And then if letter, which would be A at that point, is in vowels, A-E-I-O, and U, and it's checking each character in vowels, then it's going to print this. And since A is a character in the string A-E-I-O-U, vowels, we did this action. We printed whatever that letter was at that position at that time. It was A, and then with the rest of the string is a vowel. So we're checking each character against a group of characters, which works because this in keyword, in, looks for membership in a sequence. And likewise, you can also use not in. So let's say for letter in word, let's just change this to not in vowels. So this keyword now says if the letter is not in vowels, we'll say letter is not a vowel. We'll just change it up a little so it logically makes sense when we output this. So now I ran it, okay, and it changes. P is not a vowel. L is not a vowel. N, T, not vowels. So what this is doing now is it is checking to see if it's not in vowels. So it uses the same logic, except as long as it's not A, E, I, O, or U, then we're going to perform the next, perform whatever we have situated for the conditional. So that's how that's going to work. So that was that. Let's do length with len. So that was how to kind of check to see if any members of a sequence are within a string. And we also can use a function called len to tell us how many characters there are in a string. So I'll say how many characters in a string. And we'll go ahead and we'll create a sentence. And then we'll say CS-112 is 16 weeks long. And it's not, I don't, currently the class is not offered in summer, so this is just going to be accurate because it's only offered in spring and fall. So CS-112 is 16 weeks long, and that's our string. We've called it sentence, and we want to see how many characters belong to this sentence. So what we can do is we can say len sentence. You could print the length of the sentence. So I'll go ahead and I'll run this. And it says 24. And it's 24 because it's not just counting each alphabet or numeric character, it also counts spaces. And to simplify this, maybe you didn't understand this because we have print, length, and sentence. We'll say length equals length. I spelled it really badly. And then we will print length here. So this, I just broke it up a little bit so you can see kind of what each, I broke that one line into two lines so you can kind of see what's going on a little easier. So we have a variable called length, and it is storing whatever the length of this string is. So we have a function that we're using, len, and the parameter is going to be a string. And we've given sentence, our string up here, as an argument. And we are going to print whatever the value stored inside of length from this action is. And in this case, it is 24. So you use len, the function, when you want to validate the input length, or you could also use it, for example, to loop a specific number of times. So it's useful in those ways. And you also, we go over another thing, concatenation. I'm sorry that my transitions are so weird. I have a list of different exercises that we're doing to demonstrate the topics, and the transitions are so they're so disjointed. Okay, so we can actually use this plus sign on my keyboard to combine strings. So we may have talked about this very early on in the semester, but since we're doing the string lecture, I'm going to double check that everybody remembers this. So we'll say first, we'll have a variable called first, and it's going to store the value of hello. And then we're going to create a variable called last, and it's going to store world. And we're going to use string concatenation to join these two together to these two strings. So I want to output this. I want to output this result of these two strings combined together. So we already know that if we print first, it's going to say hello, and if we print last, it's going to be world. But if we want to print them together as the same output, we can say first, a plus sign, and then let's put a space here. We want to add a space, and then last. And this works because each of these are strings. So this is a variable that's storing hello. This is a string literal, which is storing a space. And then this is another string variable called last, holding the value of world. And this should print hello world with a space in between. So I'll run it, and it does just that. In fact, the only way to make that more perfect is to put an exclamation point after world. And you can also use you can also use plus equals, like a plus equal sign put together to build strings up gradually. So I'll make a new variable called message, and I will say, we'll give it the value of hi. And if I want to, let's say I want to add something to this, I'll say plus equals space there, and I will print message. So I run it, it says, hello there. So this is a perfectly acceptable way to add things to the string. Remember how I had mentioned before that strings are immutable, and so you can't just directly change them once they've been made. You have to kind of, in essence, create a new string, even if it has the same name. You have to create a new string to change it, and this does that. This achieves that. Notice this little equal sign here. This is increase and assign. So it's reassigning. And so that's why this works. All right. And then we can also go over a way to create duplicates. So repeating strings. We'll say repeating strings. And we'll say echo equals ha times a 3. So what we're doing here is we're trying to repeat a specific string multiple times. And then we'll print the results of this so you can see what it does. So when I run it, it says ha, 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 which is like laughing, but it's this string multiplied by 3. And then the result is the 3 of those strings in a row. And this is fine. You can actually use this operation with a string. This will work. But you can't use a plus sign or really anything else and expect it to work. It has to be a multiplication sign to show that you want to repeat it. You can't like divide by numbers. You can't like subtract numbers from it. That's not going to work. We also have a way to change case. You use upper, the function upper, and lower. Yeah. So like, let's say we'll make a name, and we'll say the name is Snubbles. And if we want to make all the characters uppercase, there's a very simple way to do that. We'll print it, the name, and then we use the dot operator. The dot operator is going to call a string method, and the method we want to call is upper. And then a little empty parentheses to signify that it is a method. I'm going to run this, and we get full caps Snubbles. And if we wanted to lowercase everything in the string, you would just do the same thing except with the word lower. You would just call the lower method. I'll run that. And then Snubbles is now a string of all lowercase. So that's what this method returns new strings, because again, strings are immutable. So that's what that's doing. And I'm going to show you, so this is one of the ways we can like format strings. So sometimes you might have a situation where you are trying to format your strings to follow certain guidelines. Maybe you're going to be evaluating a string and all the characters need to be lowercase. There's also other methods that are important when we're considering formatting strings, and that would be trimming white space. And white space are those, they're just spaces in your string, And they can cause bugs when you're doing tasks like checking an input or comparing strings with each other. Those white spaces can make that task difficult. So we'll say it will make a string called messy, and it's going to have a bunch of white space. So we'll say 1, 2, 3 white spaces, and we'll say hello world, and then 1, 2, 3 more white spaces. So this is a messy string. And we want to remove the white space from the string entirely, or at least like from the left side and the right side. And so we will print messy, and then we again use the dot operator, it is string method, and we will type in the word strip and then empty parentheses. And then this should output hello world without white space on the left and right sides. So I'll run this and it says hello world. Notice we still have the space in the middle though. So this works on the left and the right. And I want to demonstrate that the middle will not be changed if I add more white space to hello world and I run it. I still have the extra white space in between hello and world. So if I was going to process this string in a different way, or if I was going to try to remove white space from the middle or another part, that task is not as simple as just using the strip method. It actually only works on the left and right of the string if there's white space there. And likewise, if I want to only remove white space on the left, I just put an L in front of strip. That indicates this is only going to affect the left side of the string, and I run that. And then it removes all the extra space from before, and we can't really see the extra space after, but I can highlight over it. And then if we wanted to do this on the right side, again, just use an R instead of an L in front of the word, the keyword, the method name strip. Then I run it. And then now you see that we have the extra space before, but nothing after. There's nothing to highlight here. And that is how we trim white space. I'm going to get rid of this, and we're going to move on to searching in strings using in, not in, and find. So we already kind of covered using in and not in, but I wanted to discuss this use case with the find method, and I also wanted to explain that in and not in actually evaluate into booleans. So when we say, let's see, we can check for substrings this way. We'll say cat in concatenate. Okay, we'll print this. Oops, no debugging needed. We'll print this result. So this is going to output a Boolean that returns whether or not this string, this part of a string, is part of another string or found within another string. So I'm gonna run it, and it says true, and that's because this small part of a string, this smaller string cat, is part of this larger string concatenate, and the value returned from this is true. So when we print this statement, the value is true. It gives us a Boolean. And I'm going to flip through some pages here and review kind of what we did before. So before we did the vowels A, E, I, O, U, and the word planet when we evaluated that, and we said if letter in vowels, so it's going to look like we did something like for letter in word when the word was planet, by the way. And then we said if letter in vowels, and we had a string A, E, I, O, U, and then we did something here. And I know it's wrong, but I'm just trying to give you the idea of what happened and explain it a little further. We had a for loop, that part's easy enough. This if letter and vowels was an evaluation of true or false. So if it was true, then we did something. And if it was false, nothing happened. And that's kind of what we had. I'll just Control Z here. So ultimately what this is doing, it is going to return a Boolean of true or false. That's what this does. And then let's change this a little bit. Dog not in. So you can also use not in this way to get the an evaluation. So dog, we already know by looking at the string concatenate, is not in it. Because this is true, so dog, string dog, is not in concatenate, because this is true, this is going to evaluate to true. And what we're going to get when we print it out is true. It says it right here. If we change this to in, we know dog is not in concatenate. This is going to be false. When I run it, that's right, it says false. And I want to, okay, so that's going to do it for in and not in. But if you want the position of a substring, so a string is the whole string, so like hello, or let's do greeting equals hello world. So if this whole thing is a string, right? And then maybe we can consider world a substring, a sub part of that. WO, this is a substring. It's part of the larger string. So that's what a substring is. And if you want the position of a substring, you can use find. So we'll say, we'll keep this as our greeting. I'll capitalize the H. And we want to output greeting dot find. We're going to use the find method. And the parameter, the parameter that the find method takes is a string. So I'm going to find, I want to find world. I want to find this substring, this piece of the larger string. I'm going to run this, and it says 6. And so I count 0, 1, 2, 3, 4, 5, 6. It tells me that this substring starts at position 6. Okay. And now, well, what happens if we don't have something? So like we'll say hi, which is definitely not in hello world. I run this, and it gives a -1. So when we get a -1, it means it did not find it. And that should help you with using this, knowing that if I use find and I don't get anything, I'm going to get a -1. And let's say you're writing a broader program, you can figure out what to do next from here if you don't find that part of, you don't find that substring in that larger string. This helps us in doing tasks like parsing and extracting for different parts. And to a follow-up to this, let me get rid of this here. A follow-up to this method, the find method, is starts with and ends with. And this is perfect for file names, URLs, user input. This method is really useful for evaluating or amending different values. So we'll say greeting, and then it's going to be, let's do our file. Let's say my file. And let's say it's a string that's holding report.pdf, important report. So we will print a file name, my file dot ends with, and then this takes a parameter. It takes a string, and this is going to be a substring. And let's say I want to see if this string ends with a .pdf. So I'm going to run this, and it evaluates to true because my file does end with .pdf. Let's try this with ends with .txt. What if I wanted a text file? So I'm going to run this, and it evaluates the false. This string does not end with, its last characters are not PDF. So I'll change this back to PDF. And so this is true. You can also use starts with. So I'll say my file starts with. And something that would evaluate to true would be like REP or something. And then I'll run this. And then this bottom one, it's going to be this one, this second print statement. It does start with REP. So you could think a little carefully about kind of how something like this would work. So let's say we're writing a program and we want to make sure that like if the user is entering a string to search for, like a string that matches a file that we have in our program, we can make sure that the file that they are looking for ends with PDF. If we're only storing PDFs, then that's all we can give. And if the user doesn't, if their whatever they put doesn't end with PDF, then we can do some other action. Like we can output like we only store PDFs here, or whatever you wanted to do, or direct them somewhere else where they can actually be helped to look for a different file. So that's kind of how these could work in a program. And again, we can build on this even further and talk about replacing text using the replace method. So so another useful string method. Let's have some text, and then it's going to say, I love Snubbles. I do, by the way. I love my dog. So we're going to use replace, and then so we will say the name of the variable, the name of the string that we want to do the replacement with, and then we use the replace method, and this takes a string, and I want to replace here the first parameter is the thing you want to replace, separated comma, and then the next string is going to be the thing you want to replace it with. So I want to replace it with my dog because I still love Snubbles. I still love her so much, and I don't want to change it. Okay, so again, we're not modifying the original, we're just creating a new version. So I want you to keep that in mind. So I'm going to run it, and it says, I love my dog. So it prints the replacement from Snubbles to my dog. So the original is, and I'll just, for posterity, I'll print the old one, and then this is the new one. So I run it. So I love Snubbles. That's the first one. That's this one. This is just whatever was stored in there. And then I love my dog. This is with the replace method used on text, the text variable that's storing I love Snubbles. It replaces this string to this new string and then outputs it because we use the print statement. All right, just two more concepts to cover. So we're just going to finish up with slicing strings. So last week you did slicing to get subsequences of lists. So you use slicing maybe to get the last four elements of a list or the first four or whatever. You got some selection from the list that wasn't the entire list, or that's usually the purpose of using something like slicing. So let's create a word variable. We'll say word equals, not Snubbles this time because I'm worried I'm gonna change her, unicorn. And to do slicing, so I want to make it very clear again, strings and lists are not the same thing. They're both sequences, and so there's some things that have similar logic. They have similar logic to each other when it comes to things like slicing and indexing. They're not the same thing. So slicing is one of those things. So we will print, let's output word, let's output a substring. So we'll take the first, so this should take 0, 1, 2, the 0th, so that's U, 1, N, 2, I. So it should just take this. So this is exclusive, up to, but not including the 3. Go from 0, 1, 2, and then stop at 3. That's what this does. So I'm going to run it, and then I get uni, which is the first 3 of unicorn. And if I just want the corn part, maybe I would like the corn part. You can actually say, so 0, 1, 2, start at 3, and then I want the rest of it. So I don't actually have to count out, okay, that's 3, 4, 5. I don't have to do that. In fact, if I just, so I put my colon here. If I leave this blank, I don't put anything after this. I say start from 3. I'm basically saying start from 3 all the way up to the end. Just get the rest. And that's kind of the power of not including an ending integer to go up to, an ending index to go up to. So this just gets the from 3, index 3 on. And then I run that, and then I get corn. See how it goes up to index 3, goes all the way to the end. And I could do something similar if let's say I want to get this unic, U-I-N-C. And to do that, I want to get the first 4 letters. I will stop up to including 4. So I gave it somewhere to end. So leaving this blank again means get all of the first ones up until this value here. That's kind of what that does. So I run that, and then I get UNIC. And there's also, you can also do this with negative indices. So I'll put a -3 here. I'll run this, and then I get ORN. So start from -3. 1, remember when we're counting backwards, this is -1, this is -2, this is negative, the O is -3. So it starts at -3, which is O, and it goes all the way to the end, and then the end is ORN, the RN after that. Oops, change that. So that's what that does. So slicing is very, very powerful for text manipulation, especially when you don't want to use loops. And then the last part of what we're going to discuss is splitting. And splitting can be very powerful. Splitting turns a string into a list. And I've used this in so many different ways just because I do a lot of text processing. And so this one's really powerful. This one's really good to know. So let's create a nice little quote here. And then we'll say, quote, learning Python is great. Learning Python is great. And I want to create a list that stores each word in the string as its own element of the list. So I'll say that's the quote. We'll create a variable called words, and we will say it's quote. So the name of the string variable that I want to split, and then the split method. Okay. And I'm going to print what this result is, the result of words after going through the split method is. So I run it. You're going to see I do, in fact, get a list. Learning Python is great, where learning is its own element of the list. Python, all these strings are members of this list. And split actually, so if you don't specify any parameters or arguments for split, if you don't specify an argument, the default is space. So it's going to separate it's going to separate the elements by spacing. So if there's a space here, by the way, from learning to Python. So okay, there's space there. Learning is its own element. All right, get the next one. Python. Okay, there's a space here. The next element. Get to that. So it's just going to keep doing that. You can, however, specify a delimiter for the split method. And let's say for whatever reason we actually just separated this by commas. Let's say we have something like that. Things like CSVs are comma delimited, so just a heads up if you need to manually edit over in a CSV, you're probably going to use split. But we say quote.split, and then we want to, all right, what do we want to split by? I want to split by a comma. So I want you to every time you see a comma, stop and then get me the string up to that point and then continue after that and just keep going. And every time you see a comma, know that that's where we're going to split from. So when I run this, I get the same result. I did click it, in fact. I'll change it a little bit so that the output will change. So we'll say learning Python is gravy, like it's good or something. So I run this, and the value did change. So we delimited by a comma. That is what we looked for to split into different elements of a list. Again, this is huge when we're working with CSV files or logs or user data. This can be really powerful. So let's just quickly review. Strings store text. They're immutable. You can access them by indexes, forward and backward, forward using positive numbers starting from 0 all the way to however many characters are in the list, and then backwards starting from -1. We loop through them with for. We could use the in and not in keywords to check the contents. We use methods like upper, strip, replace, find to work with them. And we use slicing and the split method for more advanced manipulations. The more you practice, the more confident you're going to get. So keep practicing with them. Try doing things like building small tools like a string analyzer or a password checker. The skills you build with strings carry over to every project. They're really useful. So thank you so much for watching and have a wonderful day.